Geometry Notes, Section 16.4, Reference and Special Angles. Definition that we talked about in the previous section, we're going to mention it again, a reference angle. It's an acute angle formed by the x-axis and the terminal side of an angle in standard position. If we were to take and put each of these into our calculator, you don't have to do it, you can just follow along with me. If we had sine of 40 degrees and sine of 140 degrees and sine of 220 degrees and sine of 320 degrees, here's what you would get if you put this in your calculator. Sine of 40, you would get 643 thousandths. Sine of 140, you would get 643 thousandths. Sine of 220, you would get negative 643 thousandths. Sine of 320 degrees, you would get negative 643 thousandths. So how is it that these numbers that all seem to be so different are getting the same answer plus or minus? Well, here's why. In quadrant 1, if we have this 40 degrees, and then if we go to quadrant 2 as 140, see if we can figure out what all these have in common. And then if we go in quadrant 3, this would be 220 degrees, and then quadrant 4 is 320 degrees. What do all these have in common? They all have the same reference angle. The distance each of these angles are from the x-axis is 40 degrees in each time. That's why we're getting these four extremely similar answers. Why are these two positive? Because as we discussed yesterday, sine is y over r, and in quadrants 1 and 2, y is positive. In quadrants 3 and 4, we're going down, so y is negative. So it's not a coincidence that if you have the same reference angle, you're going to get the same answers, either some could be positive and some could be negative. Let's check out trying to clarify what a reference angle is. So find the reference angle. In this first picture, the reference angle is going to be formed right here. It's formed by the x-axis and the terminal side, and it's acute. The degree measure of that reference angle is going to be 30 degrees. Negative 100 degrees. Negative 100 is going to go in this direction. It's going to fall into quadrant 3. The reference angle is this angle here. Now if you go 100 in this direction, there's 80 more to get to 180. So the reference angle is 80 degrees. Note, it is positive 80 degrees. A reference angle is defined as being acute. Acute is between 0 and 90. So a reference angle is always positive. This last one, we got 23 pi over 12. This is in radians. So we need to figure out where this is going to fall. Let's mark our quadrantal angles by using pi over 12s. On the positive x-axis is 0 pi over 12. Make a complete revolution, it's 24 pi over 12. Halfway around will be 12 pi over 12. Halfway between 0 and 12 will be 6 pi over 12. So we got 0, 6, 12. We're going to have 18 pi over 12 down here. And then finally back to 12 pi over 12. 23 pi over 12 is just short of 24 pi over 12. I said 24, it should be 23. How short is it? It's short exactly 1 pi over 12. That is the reference angle for this. So we got 23 pi over 12 to here, add another pi over 12. That is the reference angle. It's formed by the x-axis and the terminal side, and it's acute. Special angles. What do you think I mean when I say a special angle? I hope you know. It means a multiple of 30, which could be 30 degrees or it could be 60 degrees. Also multiples of 45. So in quadrant 1 would be here. These are called special angles because they make special right triangles. This 30 degrees, if we make a reference triangle, in a 30, 60, 90, there's a special relationship. What I like to do is I like to call the smallest side in the special right triangle 1. So right now I'm saying y is 1. Then from there, I just choose, well, I don't choose, the numbers are chosen for me. The hypotenuse is twice as big as the short leg, so that means r, it has to be 2. And the long leg is always the short leg times the square root of 3. That's going to make x the square root of 3. Now, if I had drawn this same triangle in quadrant 2, the only thing that would be different is that the x value would be negative square root of 3. R is still 2 and y is still 1. If I drew this triangle in quadrant 3, x is still negative. This time y is negative 1. R is still 2. The radius is always positive. If we drew the same triangle in quadrant 3, y is negative 1, x is positive square root of 3, and r is 2. Notice that the numbers don't change if you have the same reference angle, but the signs for x and y can change. This next picture, 60-degree angle, make a reference triangle, 30 on top. This is the same triangle we drew here, it's just a different orientation. Make the smallest side 1, that's the short leg, opposite 30 is 1. The long leg is that times the square root of 3, and the hypotenuse is double the short leg. So it's 1, square root of 3, 2. If we were to draw this in quadrant 2, we would find that x is negative 1 and y is positive square root of 3, r is still 2. If we draw this in quadrant 3, y is also negative, r is always positive. If we draw it in quadrant 4, y is negative, x is positive, and r is always positive. Each of these cases, we're saying this reference angle is 60 degrees. If we draw a 45, 45, 90 reference triangle, and once again, I like to make the smallest sides 1. Each of these legs are the same. The hypotenuse is going to be that times the square root of 2. If we draw this in quadrant 2, x is negative 1, y is positive, r is always positive. Draw this in quadrant 3, both x and y are negative, r is always positive. If we draw this triangle in quadrant 4, x is positive, y is negative, r is always positive. So what is the value of this? Big picture, here's what we're after. Without using a calculator, if I take a multiple of 30 or a multiple of 45, so that's 30, 60, 90, 120 degrees, 150, etc. 45 degrees, 90 degrees, 135, 180, etc. And if I said to you, what's sine of 30? You should be able to tell me without a calculator. What is tangent of 60? What's sine of 135? What's cosine of 180? If I ask you any of the 3 trig functions for any angle that's a multiple of 30 or 45, you should be able to figure it out. That's what we're trying to accomplish. Let's check out this. Cosine of 120 degrees. 120 degrees is going to fall into quadrant 2. If that's 120, what we really want to know is, what's the measure of the reference angle? Well, that reference angle is going to be 60 degrees because 120 plus 60 is 180. Draw your reference triangle, making sure that one of your legs is on the x-axis. This makes a 30, 60, 90. Take the smallest side, which is opposite 30, make that 1. You got to be careful. I just made a mistake. I'll come back to that in a second. The hypotenuse is twice as big as the short leg, and the long leg is the short leg times the square root of 3. Now, the part you got to be careful about is you got to make sure that you have your signs correct. This 1 should be negative because we went left. Square root of 3 should be positive. We went up, and the radius is always positive. So what's cosine of 120 degrees? Easy. It's x over r. So that's negative 1 over 2. Cosine is x over r. It's the adjacent leg over the hypotenuse. What's sine of 210 degrees? Well, 210, that's going to fall, let me draw a separate picture for this. That's going to fall into quadrant 3. Here to here is 210 degrees. What's that make the reference angle? Well, it's 180 from here to here, so the reference angle here is going to be 30. Picture is not drawn to scale. You can choose the length of any side to be anything that you want. I'm going to choose the smallest side to be 1. Opposite 30 is the smallest side. The hypotenuse is double that. The long leg is the short leg times the square root of 3. Make sure your signs are correct, and I have 2 signs that are wrong. X is negative and Y is negative in quadrant 3 because we went left and down. What's sine of 210? Well, it's Y over R. That's negative 1 over 2. That's negative 1/2. I think this is awesome. And if you don't, there is something wrong with you. Now let's crank this up a notch and check out radians. 5 pi over 4. So let me just mark my quadrantal angles here. If I count by pi over 4, I got 0 pi over 4. 1 pi is 4 pi over 4. All the way around, 2 pi is 8 pi over 4. Halfway between 0 and 4 would be 2 pi over 4. And then, so my numerator goes 0, 2, 4. This would be 6 pi over 4 down here. Hopefully you can see that 5 pi over 4 falls halfway between 4 and 6. So halfway would be here. How much further is 5 pi over 4 than 4 pi over 4? It's pi over 4 further. What is pi over 4? Pi over 4 is the same thing as 45 degrees. Because this is 180 divided by 4. 180 divided by 4 is 45. This reference angle is 45. This is a 45, 45, 90. In a 45, 45, 90, both the legs are the same. In quadrant 3, they're both negative, so I'm calling those 1s. And the hypotenuse is that times the square root of 2. The radius is always positive, so it is square root of 2. Sine of 5 pi over 4 is y over r. That's negative 1 over the square root of 2. Be nice if this was rationalized. If you rationalize it, you're going to get negative square roots of 2 over 2. What's cosine of negative 2 pi over 3? Let me draw a picture for that. Always want to draw a picture for these. Excuse me. Negative 2/3 pi is going to fall in here. So let's discuss. Pi is 180, so negative pi is from here to here. This is 2/3 of the way from here to here, which means we are missing a third of pi. 2 pi over 3 plus pi over 3 is going to make 3 pi over 3. Triangle is not drawn to scale. Pi over 3 is the same as 60 because pi is 180. 180 divided by 3 is 60. That makes this other angle 30. 180 divided by 6 is 30. Make the smallest side 1. Hypotenuse is double that. And the long leg is the short leg times the square root of 3. We're in quadrant 3, so x and y are both negative. Cosine is x over r. X is -1, r is 2. We are finished with that problem. In each case, I'm going to draw a reference triangle, making sure that I have a special right triangle. On the flip side, we're supposed to take 30 degrees, change it to radians, figure out what sine, cosine, and tangent are of that. 30 degrees is in quadrant 1. 30 degrees is the reference angle. So I like to make the shortest side 1. That's going to make the long leg square root of 3. It makes the hypotenuse 2. This happens in every 30, 60, 90. First of all, we're supposed to change this to radians. 30 degrees into radians would be like multiplying it by pi over 180 degrees. We can cancel the degrees. We can divide top and bottom by 10. And then we could say, well, 3 goes into itself once, 3 goes into 18 6 times. This ends up as pi over 6. Once again, 30 is 1/6 of 180. Pi, which is 180, divided by 6 would be 30. So this is pi over 6. What is sine of 30 degrees? Well, sine is the y over r. It's opposite leg over hypotenuse, so that's 1/2. Cosine is the adjacent leg over hypotenuse, x over r, square root of 3 over 2. Tangent is a little more complicated. Tangent of theta is y over x, and you're thinking, well, that's not complicated. It isn't, but we don't like radicals on the bottom, so if we rationalize this by multiplying it by square root of 3 over 3, by multiplying it by square root of 3 over square root of 3, we're going to end up with square root of 3 over 3 for tangent. Then over here, we got more to the table. Give me a negative version of this degree. Well, 30 degrees, if you want a coterminal angle, going to subtract a complete revolution. That's negative 330 degrees. If we take the radian angle that we have, pi over 6, and subtract a complete revolution, we're going to get negative 11 pi over 6. This is a complete revolution because one revolution is 360 degrees. It's also 2 pi. 2 pi is a fraction with 6 on the bottom is 12 pi over 6. Now we're supposed to do pi over 2. Let me draw a triangle for this. Pi over 2, hopefully you know by now, is on the positive y-axis. Now, if you have a quadrantal angle, you cannot make a special triangle, which makes this even easier. So the degrees here is 90. We don't have to do much work for that because we know it's on the positive y-axis. So what's x on the positive y-axis? 0. What's y? I can choose it to be whatever I want because this circle could be as big as I want. I like to choose 1. R has to also be 1 because r is the radius of the circle and y is the distance from the center to the circle vertically. So those both have to be the same thing. What's sine of theta? Sine is y over r. It's 1 over 1, which is 1. Cosine is x over r. That's 0 over 1, which is 0. And tangent of pi over 2 is 1 over 0, which is undefined. That may be shocking to you, but tangent of 90 degrees is undefined. I need a negative version of this angle. Well, this is 90 degrees. If I go this way, it's going to be negative 270 degrees. And as far as radians go, if I'm counting by pi over 2's, and I go in the negative direction, it's negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2. Or you can just, do the whole coterminal angle thing by adding or subtracting complete revolutions. Now, this last part may be a bit of a stretch for me to ask you to do this, but I got confidence in you. You know what? I take that back. I don't have confidence in you. Let's not do this part. We'll exclude this from the homework as well, any part that asks us to find the angles. We're not ready for that.